Okay, cool. We got the recording going. All right, so quick recap of Lecture 1. As I mentioned, with this class, we're really going to focus a lot on doing projects, making sure you get practice with coding. I saw 12 of you in lab on Wednesday, and as you saw, we just knocked out 4 problems there just to get you used to actually writing code. And so the big projects, Wordle, it looked like there's a lot of enthusiasm for that project, so I'll confirm that as a project, and we'll start that in September. The Blackjack AI one, I'll talk to some of the other TAs and see what other project options we have for that, and I'll get back to you all on the final project. EdSTEM, if you haven't joined already, I think we have 44 people that have joined, so we're pretty close to the top. But if you haven't already, this is the link, bit.ly/edstem110. Make sure you join it. This is where we have all of our critical information. So I have a post here at the top called Important Links and Info. Has my email address, office hours. People had asked for how they can get access to the lecture slides. So at the end of each lecture, I'll put in the recommended textbook reading pages, the slides link. So here you'll have access to the Lecture 1 slides. After today's lecture, I'll link to the Lecture 2 slides. And then recording, I'm in the process of getting Lecture 1 up to YouTube, but that should be up soon. And then I'll put up Lecture 2 as well. And so this page will keep growing as the semester goes along. And then before exams, if you want to go back and look at a topic, I guess one thing I should add is the kind of topics covered. And so I'll go back, and this one was just CS overview, but for each one, I'll kind of put the topics covered so that later when you go and want to review certain slides, you'll be able to find it pretty easily. But again, everything will be here through EdSTEM. For the textbook link, I told Lecture 2, but I forgot to tell you all. Textbooks are very expensive. This one's $150. And so I just went ahead and bought a copy and then put it here in the Google Drive so you can download it for free. Don't rat me out to the Pearson reps. I don't want to get in trouble for doing it, but I don't want to make each of you pay like $150 individually. So go ahead, download this first 8 chapters because that's all we're going to be covering for this course. Once you click on it, it'll load, and then you can hit the download button just so you have access to that. Any questions on that? Okay. Cool. And then later at the end of the semester, you can also download the entire textbook because your Programming 2 class will use the same textbook. Finally, I put up a link to the syllabus. I covered the main syllabus points in Wednesday's lecture, but wouldn't hurt to just scroll through and take a look on your own time. One thing I want to call out that I didn't put on Wednesday is there's a section here for like the disability section. So if you need, more time on tests, if you need certain accommodations, read through this section, and Morehouse is very supportive of being accommodating, and I'll be very supportive as well. So read through that, and you can contact the number there.
So,
yeah.
Going back to the chapter.
Yeah.
The textbook, would it always be in this EdSTEM thing?
Yeah. So the EdSTEM will link you to the Google Drive. So that's how you can get to the Google Drive and download it. Yeah. Yeah. You don't have to download it. It can help, but obviously if your computer is like low on space or anything, yeah, you don't have to download it. Yeah. 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 So joining the EdSTEM, it's this join link here. So you can either visit it now or write it down, but it's bit.ly/edstem110. And you just have to sign in with your Morehouse email. Any other questions before we move on? All right. All right, silence phones again if you haven't already. Okay, the next thing I want to share, career opportunities. Again, it's day 2. I don't want to overwhelm anyone with career stuff. Obviously, the first focus right now is just, getting going in all of your classes. But I will mention there are activities starting next week, and at the least you get free food and swag if you show up for the Monday activity. So if you have an hour and you just want to, get your feet wet, it's not like they're going to interview you at this meetup. It's just for you to get a chance to talk to previous Morehouse alumni or Morehouse upperclassmen that have done internships in industry, and just so you can start making the connection. So you can get their email address, you can get their phone number, and then later in the semester, if you are interested in applying, you'll have those contacts already made. It was really interesting. One of the people who just graduated came into my office on Wednesday just to introduce himself, and he said he had a Google in Residence professor who encouraged him to apply for the Google internship. He got it. He did another internship the following year, and now he's converted to full-time, and he's going to be working at Google full-time in Seattle. And so it's kind of cool to see the impact that this first class can have in taking the first steps to get into industry, if it's something that you're interested in. Obviously, if you want to go into grad school or stuff with research, Dr. Amos Johnson came in and introduced himself. He'll have more knowledge on that front, but I personally will have more knowledge on industry. And so again, if you're interested, here's the RSVP link. You can either write it down now. We'll also have a Google Recruiter and also Ernest Holmes, for those of you who know him from Codehouse. They're both going to be coming on Monday to share more about this, but just wanted to get it on your radar now. Any questions on that? All right. Cool. So enough of me talking. Again, we'll get into groups of 2 to 4. People around you, you can move around your chairs. Share your name again, and then just how your first week on campus has been. So anything that's excited you, surprised you, stuff that you found useful that you think other people might find useful. We'll just go ahead and talk for a little bit. So, go ahead. Thank you. All right, we'll go 30 more seconds, wrap up conversations. Alrighty, let's bring it back. Cool. All right. So we're going to hop into the CS overview. Again, there's going to be a fair amount of jargon. It's okay if you don't follow everything. My main idea is just to give you an overall overview of how programs work. So before we hop into it, does anyone know the difference between software and hardware? Yeah.
Software engineering is more, software is more like the internal work of the computer, i.e. coding and stuff, and hardware is more of the outer surface of the computer with like electrical engineering and stuff like that.
Cool. Yeah. So I think that's a good way of remembering it. Software, as you said, is kind of the code or the set of instructions that are installed on a computer. So we kind of talk about it like software applications. So on your phone, apps like Instagram, the camera app, Facebook, anything like that, that's what we consider software, because it's a program that some developer has written code for and allows you to do cool stuff on your phone. However, we still need inputs and outputs, and that's where hardware comes in. So on your phone, it's the actual device. So the camera device, the keyboards that you're able to input information into the phone. In Instagram, you can't do anything if you don't have the camera to actually take the photo and the memory to save the photo. So those are the hardware components. And the two work together. You know, if you only had hardware, then your phone would be kind of useless. It would just be like this hard device that doesn't do anything. And if you only had software, well, then you wouldn't be able to access any of the data, you wouldn't have memory, you wouldn't have any inputs or output devices, and so you need both of them together. In this class, we're going to be focusing more on software. If you're interested in hardware, that's where you would take classes like robotics, where you would actually be building out some of these devices.
One second.
Yep. Any questions on that? Yeah, Freddie?
Like Google or like different like tech companies like that, which side of the spectrum do you feel like is more valued, like as a career or as a job?
Sure. What made like companies like Google, Microsoft, Facebook big was their software. For Google, it's like their search engine. For Microsoft, they initially started off as a hardware company because Microsoft made their devices. But now if you look at stuff like Teams and Outlook, Microsoft is trying to get more into software. Generally, software is considered a little bit more profitable because you can keep doing like a subscription service and you can keep charging more. Whereas with hardware, once you sell the device once, unless you're like something like Apple where they've really hooked people and they get you to buy the iPhone or whatever it is every like 3 or 4 years, it becomes a little bit harder. So most tech companies and more of the jobs are in software. Cool. And so how does it actually work? Software will use human readable languages. So this will be programming languages like Python, C++, Java, stuff that when we as humans read it, it kind of makes sense. Hardware will use what we call as binary language, which are all just zeros and ones. And essentially, that's how the machine is able to understand. It's able to convert those zeros and ones into actual programs to do stuff. And I'll show an example of how the software code programming languages get converted into binary. Okay, so you have a programming language, kind of like it could be Python, where you write some code. The code will go through what we call a compiler. And a compiler will convert the programming language into machine language or binary. So it'll take the code we write and we convert it into zeros and ones. Compilers are pretty complex. I think Morehouse has a compiler class that you can take later as an upperclassman to learn the inner workings of how the compiler actually processes it. But for our understanding in Programming 1, we don't really need to know the inner workings of how this compiler works. All we have to know is that the compiler expects very certain syntax. So for those of you who came into lab, you'll notice that in cout, if you made the C capitalized, then the compiler wouldn't know what that meant anymore, and it would give what is called a compiler error. So when you run code, let me give an example here. So in the Scratchpad, if we were to run code and we were to make this cout capitalized instead of lowercase, and we were to run it, this is what's called a compiler error. And the nice thing is the compiler will tell us in this console what the error actually is. And so it's saying cout was not declared, which is another way of saying like the compiler doesn't know what cout is because we didn't capitalize it properly. And so if we were to make it all lowercase, now the compiler will understand what cout means. And if we were to run it, then the code will execute as we intended. Are there any questions on that? Okay. And so our job in Programming 1 we'll learn these rules for how the C++ compiler works and the inputs that they're expecting, and we just have to make sure that we type that correctly when we code our programs. Those zeros and ones will then be processed by the computer hardware. Hey, Dr. Watkins. The zeros and ones will be processed by the computer, and then it will do stuff. So just as we printed hello to the console, that was the computer literally taking those zeros and ones and converting it into output that we as users can understand and interact with. Okay, so for each programming language, there's a different compiler. So Python has its own compiler, Java has its own compiler, and C++ has its own compiler. That means they each have their own specific rules and what we call syntax. Just to show kind of the difference between a concept and syntax. So let's look at normal everyday languages, kind of English and Spanish. In English, we put the adjective before the noun. So we would say, my favorite fruit is an apple. But in other languages, like Spanish, you would actually put the noun before the adjective. So you'd say mi fruta favorita. Both mean the same thing. Conceptually, they're both saying that my favorite fruit is an apple, but the way we express it, the syntax or the grammar, as we would call it in English, is different between the two. And so that would be an analogy for the difference between Java and C++. Both will have the same concepts. They'll both have for loops. They'll both have if-else statements. The difference is the exact syntax, so the punctuation, the vocabulary we use, the ordering. Those will be slightly different between the languages. And in our class, we'll be focusing entirely on C++, but once you learn C++, it will be easier to go and learn other languages because they will look very similar. Any questions on that? Yep. And so when you're coding, some of the errors that will come up, one will be the compiler error, the other will be like a syntax error. So if you forget to add a semicolon, that's forgetting certain punctuation. And so that will say, syntax error, it looks like you forgot to put a semicolon at the end of the line. Go back and add the semicolon. Cool. All right, final slide I have for CS overview. Again, this is going to be a lot. Most of these words I kind of had to look up myself as well, just to get a refresher. So don't worry if you don't get all of it. At the top, we start with source code. So in the EdStem, that was the code that I showed you where we print out hello world. That code will go through a preprocessor and additional code will be added. So for those of you in lab on Wednesday, the very first line we include in our code is include IOStream. And so what that's saying is include other code that already exists and put it into a new modified source code file. So if our code was initially 10 lines, now it might become 100 lines at the modified source code step. After we've included all of this additional code, then it goes through the compiler. And if there's any syntax errors, then the compiler will raise an error and say, there's a compiler error, go back and fix it, your code won't work. If it makes it through the compiler stage, great. Then it'll go to the last two things, which are like object code and linker. You don't need to worry too much about that. And then executable code. So that's when we press the run button. Now it will actually execute, and the code will run, hopefully, as we intended. And so kind of preprocessor to linker are all taken care of us by the computer. That's what your Windows computer or your operating system, like your Mac, will already take care of for you. And so the parts we just need to worry about are the source code at the very top, and then the executable code at the end, because that will be whether the output matches what we expect. But I just wanted to show you all the steps just to kind of give you a slight idea of what it looks like in the background. Any questions there? Okay, cool. And again, I'm not gonna test you what are the 6 steps that happen with code. It's more just for your general understanding. Okay, so we're gonna hop into data values. Now would be the parts where I'd expect you to really get it, take notes. You'll be using this when you write your code, and it will be there on exams as well. So we're, again, going to get into groups of 2 to 4. Again, if you need a reminder, share your names again. And for this assignment, I'll again pass around some paper. And we're going to pretend that you're an NBA general manager. The NBA draft is coming up, and you're deciding which players you want to draft onto your team. And I just want you to write down different information that you would want to know about the given player. And even if you don't follow basketball, just think about general stuff you'd want to know about their person. So I put down the example of name or position, what other general information would you want to know about the player? And then we'll come back together and share some of the ideas.
Off rip, I need to know your hustle stats. You need to see if you're taking charges, how your defense is, you diving for the ball, you want to put your scrappy.
Think about how we can define these as metrics. So obviously you want someone good at defense. How do you write that as like a metric? Something with stats.
Look at
fit with your team.
We're gonna look at the turnovers. Your man got too many turnovers. Right tight. Also, we'll look at what conference he did, what team he Right. Slowing this shit. Body type. Talk about height.
We'll give people 1 more minute.
Wingspan. What else? Body type. Build. Conference.
What's your number?
And then we got hustle stats.
You shoot off the dribble for sure. You gotta be able to shoot off the dribble.
Okay, let's start bringing it back.
You can't teach effort.
Okay, so we'll go around the classroom. We'll start here and snake our way around. So just give me one of your points.
Teamwork.
Okay. Team oriented. Okay. Is there a way we can measure that?
How they get along with their guys they are leaving, like the team they're already leaving from.
Okay. Cool. So maybe we'll do like coach/player recs. Okay. Next group.
Said mentality and effort.
Okay. Mentality and effort. And how can we judge that?
How they react to certain things when they're playing.
Okay.
Body language and facial expressions.
Okay. Next group behind them.
Defense.
Okay. Do you have any defensive stats we can use for that?
Stoppage rate.
Okay.
Yeah,
Steals. Okay.
Plus minus.
Cool.
Defense, yeah, plus minus, yeah.
Okay. So we'll do like steals per game, plus minus. Cool. Group behind there. Oh, sorry. You all were together. Yeah.
We said just like height and weight, like body stuff.
Yep. Height, weight. Cool. Good to know. All right. This group here.
Field goal percentage, 3-point percentage.
Yep. So we'll just call it like shooting percentages. Cool. Next group.
Some of the body percentages, we had wingspan, age,
Yep.
and also weaknesses.
Okay. Okay. This group here. Or sorry.
Vertical.
Vertical. So their jump. Yep. Okay. Final group. If there's anything remaining.
Like overall stat line.
Okay. Yeah, I guess we can kind of group that. But yeah. Yeah. So like points per game. Yeah, rebounds per game. All that. Okay. Cool. So we're gonna come back to this. I promise I didn't have you just do this for no reason. But before we come back to it, we're just gonna quickly talk about how this ties into data types. So when you're learning a new language, such as English or Spanish, we kind of, if you go back to when you started in kindergarten, you first just learned kind of vocabulary, right? You saw a picture of a cat and you learned this is a cat, this is a dog. And then you built your way up to phrases like the cat is red, the dog is barking. And then you put those into larger sentences. You know, the red cat likes to meow when it's sunny outside. And each grade level, the sentences became more complex, and you learned more and more. And in programming, it's going to be very similar, where today we're just going to start off with values, and specifically data types. Then we're going to learn how to put those into expressions, and then overall into statements. And I know I didn't explain what expressions or statements are. We'll cover those in the future lectures. But for now, data types, you can think of them kind of like parts of speech. So in English, you have nouns, adjectives, verbs. And the reason why it's important to distinguish them is that you can only do certain operations on certain types of speech. So if you want to make something past tense, you can only do that to verbs, and you add an ed to the end, usually. So, if it was something like reserve a table or reserved a table, that would make it past tense. You add that d at the end. But you can't do add an ed to a noun. Let me think. A lot of my nouns are also verbs. Shirt. You can't be he shirted that, right? It wouldn't work. And data types are very similar. The reason why we distinguish between data types is we can only do certain operations on certain data types. And so today we're going to start with our first 4 data types. I think in total in this class we'll maybe learn 6 to 7. Are you in programming 1? No. Okay, cool. I think over the course of this semester we're going to learn 6 to 7 data types, so we're already more than halfway there with this start. And it breaks into 4 categories. So the first is an int, which are just whole numbers. There's gonna be a dedicated slide for each of these, so don't worry if you don't pick it all up now. String, you can think of as a string of characters, kind of like a word or a phrase or a sentence. A double is a number with a decimal point, and then bool is true or false. And we're gonna go into more detail for each of these. That's just the high-level summary. So first, hey, Dr. Watkins.
I'm trying to start collaborating.
Yeah, go for it. I wrote down the attendance names here, but still don't have access to Starfish right now. Okay. So we'll start with int. Ints are short for integer. So for those of you who took algebra, you'll remember integers are whole numbers. They can be positive or negative. They can also be 0. And the key distinction is that they don't have any decimal points in the number. So can anyone try to think of an example? 2? Yep. Any others? 7, 0. Yep. How about a negative int?
-1.
Yep. Cool. So you all pretty much hit the examples I have here. It can be 0, it can be a positive int, it can be negative. The important part is that there's no decimals. So it's not 5.0, it's just 5.
Give me 1.
Yep. Oh, sorry. Are there any questions on that? Yeah. Cool. The next one is double. So int and double are our 2 numerical data types. And the difference with doubles are that they are decimal numbers. They can be positive or negative. And so can people try to think of examples for doubles? Yeah. 4.3, yep. Others?
3.8.
3.8, yep. How about a negative one?
-5.5.
-5.5, yep. Yeah.
Is there a difference between doubles and floats?
So a slight difference. Floats are also, they include decimal points. Generally, doubles can, it comes down to memory, so how big the data type is. Doubles are essentially twice as big as floats in memory, so they can just store more numbers, essentially. The way modern C++ works is even if you define a data type as a float, it automatically gets stored as a double. So for this class, I'm just going to teach doubles because that's what the compiler does anyways behind the scenes. Okay. One thing I want to point out, the examples people gave, they all had 0.5, 0.3. That all works. But remember, even if it's 0.0, if the decimal point is there, it will still count as a double. So 0.0 versus on the previous slide we just had 0, they're different because of the decimal point. Even though we as humans understand them as the same thing, the computer takes things very literally and will consider them as two different data types. Any questions on that? All right. The next one is string. So this is text. I kind of like to think about it as a quote. If you were to quote someone, you would put it in double quotation marks, and you would put down what they're saying. The reason, I don't know if it's the reason, but an easier way to remember that string corresponds to text is you can think of it as a string of characters. So you can have like a string of 5 characters or 10 characters. They can be sentences, there can be spaces, they can be special characters, and there can even be numbers in the string. But as long as it's in double quotation marks, they all count as strings. And so for this one, because it's kind of hard to say quotes around everything, I'll just put up the examples. And the one I want to highlight is 42. It looks like an int, but because it's in double quotes, the computer is going to interpret it as a string. Any questions on that? Strings are what we use to print stuff out to the console. So again, for those that already came to lab or will be coming today or Monday, all the lab 1 problems revolved around printing stuff out to the console. And if you remember, they will all have double quotes around it. So in our Hello World example, we made sure to put double quotes around it. That's how the computer knows it's a string, and that's how it's able to print it. Cool. Okay, our final data type is bool, and these are used to express what we call conditional values. Either next week or in 2 weeks, we're going to get more into conditional values. For now, I just want you to know a bool can only take 2 values. It's either true or it's false. And it's useful for stuff like when you go to an amusement park, are you tall enough to ride the roller coaster? Either yes or no, true or false. You can check whether 2 things are the same. So whether 2 names are equal, it's either yes, true, they are equal, or false, they are not. Right now, this seems kind of useless. Like, why do we have a special data type just for these 2 values? But they will become more useful in a couple weeks. So for now, you can just remember it as true and false. And remember, there's no quotes around it. If we were to put quotes around it, what data type would it become? String. Yes. Good. Okay, so now we're going to take all the work that you all did. Let's copy it over. Paste it here. One thing I'll add is injured. Okay. So we're now going to say what kind of data types each of these are. So we'll start with steals per game. Does someone want to take a guess what data type that would fit under? Yeah.
Wouldn't that be, what you call it, double?
Yep, so it'll be one of the numerical ones because it's a number. It's a double because generally when you take averages per game, you'll get something like 2.3 steals per game. And so because it has that decimal and it's not always a whole number, we want to store it as a double. All right, how about plus minus? Yes, if we do, we'll do plus minus per game. Yep, if it was per game and we're taking the average, then it would be a double. Height, we'll say like height in, yeah, okay, height in general. Again, that would be, this one is flexible. You know, if we do it in inches, it depends on who's measuring it and how specific they are. But just to be safe, because you could have like half inches, it is safe to like put it as double. Kind of same as weight, shooting percentages. How about age? Okay. Yeah, so generally, even though, you know, you can have like in between ages, typically when you see the age stat on a player or a student, it'll just be a whole number. And so for that one, it makes sense to do it as an int. Okay, so for team oriented, we said like you maybe collect like coaches and player recs, like you get information from their fellow coaches and players. How could we store that data? Yep. And so we're literally like getting quotes from these coaches and players, so we'll store it as a string. And then the final one that I added is, draft day's coming up. We want to know, is the player injured or not? Because that can affect where they go in the draft. Bool, yes. So it's just going to be a true or false. Awesome. Cool. So we're going to get into an interactive activity. There's a game called Kahoot. So let me start it. Classic mode. Okay. So either on your computer or on your phone, you can go to kahoot.it. Yep. This top one here. You can just put in your first name once you join. You like the music, Dr. Watkins?
Yes. Fighting the urge to dance. Yes, absolutely. Just by the way, John is on.
Okay, cool. I've also recorded the lecture, so I will send it to him as well. Yeah. Okay, I think we're just missing 2.
Yeah.
All right, so we'll go ahead and start it. Okay. Whoever needs to join. Essentially, this is like a mini competition. You get points first and foremost for getting it correct. So accuracy is most important. The tiebreaker is the speed with which you answer the question. But make sure you get it correct before you type it in. So we'll start it now. I see 23. It's going to be on data types. And each question is going to ask you what data type you think it should be. So 5805. On your phone or computer, you'll see red, blue, yellow, and green. Oh, sorry.
Your screen, they don't see it on there?
So on your phone or laptop, mark down the color that corresponds to the right answer.
That's a lot of time.
The other ones are 20 seconds, I think, just for the first one. Int, all right. Majority got it. Does someone want to explain why they think it's an int? Whole number, no decimal point. Cool. All right, Kedar up top to start. True or false, the following is a string data type, in quotes 5805.
Oh my God.
Lock in the answer. Going for speed, not accuracy.
Oh, the answer is true. Does someone want to say why it's true? They got the quotes. I feel like people realized it after they submitted. So, accuracy is first. You don't get points for being fast unless you get it right. We got some change. All right. Negative 5,805.2.
Floats and doubles are the same thing, right? Because it's
Oh, shoot. Yes, I'm sorry. Floats. Oh, I need to update the quiz. My bad. All right, that one's on me. Sorry. Float should be double. I'm sorry about that. Oh. A lot of you still got it. That one's on me. I think the other quiz questions also say float. It's supposed to say double. That one's on me. I'm sorry. All right, the following data type. True. All right. So for the string, if the true was in double quotes, then it would have been a string. But in this case, because it's just as it is, it will be a bool. Cool. So now we're going to get into, pretend we're selling a used car. So, if we give you the data type, it's generally we can figure out what it is. A lot of coding is taking real world problems and mapping it to computer code. And so it's making these what we call design decisions, kind of how we did on the slide here, where for each of these, how do we want to represent the data? That can really distinguish like a good engineer from a great engineer, is these decisions you make. And so for this part of the quiz, we're going to pretend we're selling a used car, and I have different things that we want to represent. So the first one is, what would represent the car brand? All right, string. String, okay, does someone want to share why they think it's a string?
It would have quotation marks around it. Basically, it's telling you something.
Yeah, so it's, car brands would be like Honda or Toyota, something like that, where it's a set of characters. So we would have to represent it as a string there. Cool. All right, the lead's getting close at the top, just 6 points. All right, miles per gallon. So cars will have data about like how many miles per gallon it will go. Electric vehicles generally have higher miles per gallons. Big trucks and SUVs have less. How can we represent that? Yep, float, which again is essentially a double. Sorry about that for the quiz. This one's kind of close between float and int. Like generally when it's advertised, you do sometimes just see it in whole numbers, but generally it can be represented with decimal points. So it'll be like 27.5 miles per gallon. Cool. We have 2 more questions. 6 players have an answer streak of 6. Nice. All right. That will tell whether the car has been in an accident before. Cool. Cool. Yeah, so in this case, has the car been in an accident before? It's either going to be a yes or a no, a true or a false. So we can just represent it with a bool. Okay, final problem. Let's see if anything changes at the top. How many seats does the car have? All right, int, yeah, so generally when you see it, it'll be like a 5-seater sedan or a 7-seater minivan, but you don't really have like, 4.5 seats. They have to, by law, every seat has to be there and has to have a seatbelt. Cool. Okay, this final question, you don't get any points. It's not time-based, it's just a poll, so take your time with it and actually answer honestly. The data won't be shared with the class. This is more for my understanding, just a general feel of how you're feeling about data types. Okay. Cool. Okay. Let me just take a picture of this. Okay. Cool. So yeah, we will have more practice with it, especially in the labs. Pretty much through the rest of the semester, we're going to be using data types in every program that we write. So there will be lots of opportunities to keep practicing with this. The nice thing with the compiler is if we use the wrong data type, we'll be able to tell when we run the code. So that will help as well. But for some things with designing, right, when we're picking which data types to use, that will just come with doing more practice and doing more problems. But we'll definitely do that. Cool. Let's see the final podium. In third place, all 8 questions correct, Donovan. Nice. Second, Jamel. Nice. Congrats. And first place, Kadar. Nice. Let's give him a round of applause. And good work to everyone for participating. Runners up, Naomi and Isaiah. Cool. Just a friendly competition. Obviously doesn't mean much, but just wanted to make things more lively. All right, we got 3 minutes remaining. Timing actually worked out well today, which is good. Okay, so again, join the EdSTEM if you haven't already. For labs, even if you were supposed to be in Wednesday lab and you weren't able to attend, make sure you attend either today's lab or the one on Monday. Today's lab is going to be from 4 p.m. to 4:50. If you're in that lab, make sure you attend. Everyone who attended Wednesday's lab was able to finish all the problems and get full credit by the end, so they had no extra work. It will take you more time if you don't come into lab because we give you help and we show you how to do the first problem, so it'll be in your best interest to come. And make sure you attend office hours. I will actually be in my office today from 2 to 4, so come by and say hi. Yeah.
Office hours isn't in here?
Office hours is in 224, right across the hall right there. Yep.
Is that our IDE? Was the thing that you were showing earlier where it was like the process and tell us what we're doing wrong? That's the IDE for this class?
Yeah, so EdSTEM, yep, that's what we're going to be using as our compiler and IDE. Yep. Yeah.
So if we signed up for a certain, let's say if I signed up for Friday,
Yeah.
they
Yeah.
can come to the Wednesday later?
Yes. That's okay.
So I pick on the other one.
Yes, ideally try to come to the one you're assigned for, but if you have to miss one in a certain week, come for one of the other ones.
Okay,
Yeah.
thank you.
Yeah.
What is the office hours? What are we doing? What's that?
I just want to build the habit of coming into office hours. You don't need to have a question initially. I'll have, Gatorade, snacks. Come by, get a snack, say hi. That's all. It'll be like less than 5 minutes if you want it to be. Also, if you didn't fill out attendance, make sure you write your name on the way out.
So I had to drop this class to change the lab, and I don't have it changed my major yet.
Okay.
So I'm gonna try and get that figured out.
Okay.
My name is Ronald Smith. I'm probably not on the roster. I was in here the first day.
Okay.
And then
This is
I
the
don't know
attendance
if
sheet?
Yeah.
I need to talk to you or Dr. Watkins, but I was debating on going dual degree engineering or software.
Okay.
So is this a requirement? Because I think it is.
I think it is. To be completely honest, Dr. Watkins will have all the information because he runs it, and I think he's teaching in here next, so you can talk to him on that. Yeah. Cool. Yeah. Hey.
Hello, sir. My name is Hector. I unfortunately wasn't in the last class because when I was registering for classes, I accidentally wrote down the wrong time. It was at 11. I looked at my schedule at 3. I was like, all right.
Yeah, that's okay. I'll put up the lecture recording on the EdSTEM there, and the slides there. So I just take what you do that, and you should be okay.
Thank you. Sorry, I really don't like being late. Or
Yeah,
missing
you're good.
anything. So you said that I can go to any office hours?
Yeah, for these times, are you talking about the office hours or the lab?
Lab.
Yeah, lab. Try to go for the one you're assigned to, but if it doesn't work with your schedule, you can come to one of the other ones. Yeah.
Thank you. And
How's the office hours isn't right?
By the nothing, but you can just call me Professor Ashwin.
All right, thank you.
Yep.
2 p.m. to 4 a.m. I will be coming to office
Sweet.
hours today.
Awesome.
Because I know I won't be able to make it to the lab today.
Okay.
So is it possible that I could come to office hours to work on the
Yep.
lab?
Sounds good. Yep.
I might also do that.
Okay.
I had an issue where I was trying to switch the lab to that later one on Wednesday, but
So was,
and it kicked me out of the lab and the class.
Okay.
But I got an error when I tried to re-register.
Okay.
Where it was saying something with the correct. It
Yeah,
was like something
they
with
put you
the.
on. So what you need to do is you need to go to the leadership building. But when I tried to
just go to the leadership building.
when I tried to switch mines over to the Wednesday, it just told me that it was full and I couldn't join it.
It's room 444 in the
Oh my,
leadership
I'm
building.
right.
All right, because it gave me an error saying I had the wrong major.
Your counselor should be, or your advisor should be able to just get you right. You should be okay.
All right, because I was just waiting on an email from him. Because I sent an email to him, but I haven't heard back yet.
Okay. Yeah. Sounds good.
Have a good one.
Yeah. Take care.
Crazy out there.
Yeah, it is. It's gonna be like that the rest of the next 7 days.
Thank the Lord.
I hate it.
Nice little